So hi, everyone. Thank you so much for joining us for our webinar today, Revolutionizing AppSec with a multi-AI agent approach. My name is Brian Lee. I'm the VP of Marketing here at Qwiet, and I'm excited to introduce to you our two speakers today, Stu McClure and Ed Amaroso. A couple housekeeping things as we get started. We are recording today's webinar, and we'll be sending out to everyone who registered via email. So if you miss any part of it or want to rewatch it, you will be getting that in your inbox. We're also going to be doing Q&A at the end, so please do submit questions into the chat. We'll be curating those, and then at the end of the discussion between Ed and Stu, we will jump into the Q&A and answer those questions live. And then finally, I want to share that this is actually going to be the first in a series on this topic about agentic AI and security. So stay tuned. We're going to be sending out some more updates in terms of upcoming discussions, who the speakers are, and we'll be looking at different aspects of how agentic AI is working with security. So that should be some additional great conversations. And with that, I'm going to go ahead and hand it over to Stu and Ed.
All right. Well, hello, hello. Hey, Ed, how are you?
Yo, how you doing?
Good, good. Well, thanks again for joining us. And I'm super excited about this topic because not a lot of people talk about it. A lot of people say they're doing it, but it's really, really difficult to sort of separate the wheat from the chaff and the noise from the signal and everything else. So let's just get on into it. So for everyone who do not know me, I'm Stuart McClure. I'm CEO of Qwiet, former CEO of Silence. We were, I guess, arguably the first to really commercialize, productize AI in cybersecurity. And my good friend Ed Amaroso here is joining us today, former global CISO for AT&T for almost 18 years, and now part of Tag InfoSphere and is the CEO there. Ed, why don't you do a quick introduction of yourself, and then we'll get it kicked off.
Well, thanks for including me in the discussion. I love these discussions. They're always kind of organic, and a lot of good ideas pop up. So I'm glad people are listening, either live or if you're in the middle of your workout right now. We'll try and keep it interesting for you. Stu, I loved the in the title when it said revolutionizing. Most of the time when I see that, I kind of roll my eyes, but with you, I don't. Like, it seems like you have a habit of doing this. Like, what is it you're drinking or doing? Can I have some of that? But
I appreciate it.
how do you get the ideas? Like, you always seem to be a little bit ahead of a lot of others. Where does the inspiration come from?
I think it really does go back to a couple events in my life. Like, one is in and around the realization that you actually can prevent bad things from happening in this world, in the physical world. And I think I've told you the story about the plane accident I was on. It was 19 and stuff. And I think that realization to me came forward not immediately, but over a decade or two of getting into cybersecurity and realizing, wow, if I can think to the root cause of a problem and I can apply mathematics, the foundational elements of the universe, and then, of course, programming to help build software around it, that we can prevent these problems at the root cause. And that's really what led me into that world of AI. It was the only solution that would give us that predictive power. So I don't know, for me too, I'm always one that's like, I'm that kid, that annoying little 4-year-old that just keeps asking why. So when somebody says, well, hackers get in so easy, and I'll be like, well, why? And then, well, because, there's vulnerabilities. Oh, well, why? And I am that annoying little kid, I think, at heart.
Well, I'll make sure to say because I said so at least 5 times today. So
Good.
but when you first told me about Qwiet, I thought it was interesting because I'd been thinking about the confluence of a few different problems. Like what you and I and everybody probably all pay attention to Cloud Security Alliance. Like, I think that's a good group. And I
Yeah.
love their concept that we'd all seen a shared security model where a lot of infrastructure stuff I've spent a lifetime doing is kind of done by somebody else for a lot of the people who are listening. And what you end up with is AppSec and data secret. That's the first thing. I knew that was a problem. Second one was how to properly use AI, because you and I both know you can misuse this. I mean, there's a lot of you have to know what you're doing. And then the third is that software has been terrible for a long time. So it's funny how when you're describing it, I went, that sort of sits in that triad of things that I've spent so much time thinking about as,
Yeah.
three of the bigger problems that exist. I don't think people worry as much about like, is the network a problem? I mean, it's still a problem, but it's usually not something. If you work in a bank, you're sitting worrying about network all day long. You're probably more worrying
Well,
about your app.
and
So
I
do
think
I
the
do
very
I have that right?
yeah, no, you're right, exactly. And the nature of, I think what we're all really striving for at the end of the day is prevention. I mean, yes, detection response is great, but man, we've got to focus in on that prevention angle again. And AI is really the only way to do it. You know, you think about where this company, Qwiet, has come from. It used to be called Shift Left. I mean, that was the name of the company. And we renamed, rebranded into Qwiet AI to present more of the value of what we're delivering, which is we're quieting the noise and we're quieting the problems. But at the end of the day, it's that shifting left, it's that going as far left as you can in the beginning of the kill chain, right? Which is, you and I both know 100% of cyber attacks, they begin and end in code. So why can't we go there? Why can't we focus there, spend the time and now really apply AI? So when I joined 2 years ago, Qwiet, I took it over as CEO, and I saw a base foundational technology with this vectorized graphing capability of code that, oh, we can apply mathematics and AI, true AI, predictive and generative, into this space. It was just a matter of time. You know, when could we get this working? And so I saw it just as clear as day as I see you right now. I can see back then, like this was going to be possible. The only question is, you know, who's going to join me to build the impossible to make it possible. So that's been a fun journey, and we've come a long way, but we've made just tremendous strides, and we're now getting to this place where, you know, talking about AI in code and especially auto fix in code, and really where we're going, which is auto test and validate, going far beyond using agentic. To me now, it becomes a real thing we can talk about. We've implemented it, it's in customer environments, and now we can prove the value. So that gets super exciting for me. I'm like a kid in a, well, I guess on a Halloween day going for candies.
I'll tell you a funny story. So your team, I don't know, a few months ago when we first started becoming aware of what you were doing, they asked me something like, and you'll laugh at this because I'm an old enough guy that I can be honest nowadays, but they
Yeah.
go, so Ed, what's your thoughts on agentic AI? And I said, I'll tell you exactly what my thought is. I don't know what it is. And then they said zero shot, and I said, "Ding, don't know what that is either." But now I do. But I think you'll
Yeah.
be the best at explaining it. It's a very
The,
interesting way of thinking about
yeah.
practically deploying AI. Tell us a little bit
Yeah.
about the difference, and assume that some of the people listening may not have ever
I have
heard.
no clue. No, exactly. And so let me back up a little bit. So the way I describe AI, now I came from the predictive side, but there is this other side which everybody's now become super familiar with, which is this generative side. So predictive takes large data sets and figures out, well, where's the separation between all these data sets so that I can label something. So that was perfect for silence, right? We looked at everything that tried to execute on a computer, and we built models on good, models on bad, and we said this is either a good thing, so allow it to run, or a bad thing, block it, stop it, things like that. So that was the predictive side. Now, generative, which is what's really come on the scene in the last few years, takes obviously a different approach. It takes a large amount of data, words in this case, tokenizes them, and then learns to predict those tokens in a sort of a forward-going place. So you can ask it a simple question in the language of your choice, and it could answer it based on the best answers that it's given or
Or what
learned
comes
over
next?
time. Yeah, exactly. And so that's why when I first joined, Shift Left was Qwiet, or now Qwiet. We looked at, okay, you had this vectorized database. You said, okay, it's mathematics anyway. Why can't we learn from good vectors and bad vectors to create our own predictive models of bad? And so within about 7, 8 months, we're able to build our own models on Java, our own models on C#, and implement that in the product. And we continue to build them. But ultimately, I think for every single, at least cyber professional, you want to be able to fix and ultimately prevent. So it's not just about finding more problems, you know, giving you a bigger list to go chase down or to harass developers or software engineers, but it really is giving you a template for success for how to engage and fix specifically. And that's where the generative side of things come. Now, the problem, of course, with these generative models, there's many problems, right? We hear about hallucinations, right, which are things that are literally just made up. Can I just tell you a funny story about this thing? It just happened to me yesterday. So I'm building this is a little sneak peek into some fun I'm doing, but I'm building a bot on me. Okay, so it's I won't give you all the details, but in essence, I've trained it on my experiences in life, my output, the things that I've produced, my books, my columns, my articles, my interviews, my whatever. And I've also trained it on all of my memories and experiences. Okay. So in essence, it's starting to become me. So if I ask it for a poem originally created by me, and I take that and I put it into an AI detector, it comes to like 40%, 50% detection, not 100, which is what it would without all that contextual data. But at any rate, I asked it yesterday. I said, hey, what are the memories that you have of me? Sure enough, it had like, I don't know, tons of memories, but like the 10th or 11th one, it was, and you served in the military for many years. And I'm like, oh gosh, okay. No, I haven't. But because I grew up in Guam, because my dad was in the military, because my brother was in the military, because my sister was in the Coast Guard, it just naturally presumed that I had a military background. And it's that simple hallucination that occurs every single time. And it occurs in code in dramatic ways. So we've seen this many times where you ask it to generate code, Copilot, GitHub, whatever, and it'll literally hallucinate whole packages, software packages that are out there in the world that the program that it's building is actually referring to. So you can just basically package squat, domain squatting, same thing, right? You package squat, you build your own package, which is malicious, and you wait for the hallucinated code to go call it. Well,
Right.
how does the developer supposed to know what's malicious or not, or what's legitimate or not? So it's these kind of problems. So hallucinations is one thing. That's probably one of the biggest. Second problem is in and around the error rate itself of just not inferring correctly. Now, this
Let
is
me
going to
back
get
you up. Squatting means I'm sitting with lurking. Would there be an injecting kind of like a more
abs. Yeah,
active?
yeah,
Because squatting
absolutely.
gives the impression that I don't have much control, but you probably do in some cases have more control than just kind of hanging out waiting to be learned, right?
You do have a lot of as an
In a
adversary.
dev environment, you can
Yeah,
stuff something knowing it's going to get sucked in.
exactly. You as an adversary, you have multiple places to sort of sit or inject into. And in this specific scenario, it was a squatting scenario that allows them to sort of just wait
Got
until
it.
somebody walks
Yeah.
by. Think of it as like a phishing email,
Yeah.
like, are you going to go click on the dang thing or not? And software developers are not trained on security. Yeah, they might go through some program for some mandatory social engineering stuff, but it isn't a part of their day-to-day vernacular as they code. So it's quite easy to get them and lure them into these worlds and get them to include your code, get them to include malicious code. And so what this means is this error rate, this hallucination rate, right, is that you can really only trust maybe 70 to 80% of the code that comes out today. Now, that means a human has to be a part of the equation. There's no other way around this today. We're just not there as a mature, what do we call it now? We're really moving to this chain of thought concept, which I'll explain later. But so we have to have humans as part of the loop. And the theory is human plus AI is far greater than AI alone. But until we can integrate the human into the AI experience in developing code, for example, we are going to have to make some improvements and enhancements to what we're doing. And that is really in and around agentic AI. Okay. So today you have a model like you can get on ChatGPT, you can go on GPT 4.0 or 401 or whatever, and you can see the differences in all of this stuff. You can go into Claude, Anthropic's model, any of these things, and you could ask it these questions, and you can see all the error rates, etc. But these are singular LLMs. Now, not 401, by the way, which I'm going to explain in just a second. But all the other models are just individual, separate
Right.
LLMs. And how you prompt that LLM to get the most accurate answer is really, really, really important. Like, for example, if you just ask it for, hey, give me a tic-tac-toe app, right, in Python, and you just give it something like that. Yeah, you'll get something that works, but it might not actually follow the rules of tic-tac-toe, for example. Yeah. So, so you really need to be very specific, very explicit, and you almost need to go to that next level of demanding for a chain of thought or thinking through the steps, because without that, it just jumps to, well, what's the next word? So to do all of that, for example, so OpenAI developed GPT 401. Now, by the very nature of 401, you get a chain of thought answer. But all the other LMs, you just simply do not get that. And so where we're going, and it really is, I think, the natural next step evolution, even after chain of thought, is to employ specific, finely tuned LLMs for specific roles inside of that life cycle of cybersecurity. So a developer doesn't want to worry about it. She wants to code, she wants to test, she wants to, send out into production, and she wants it to work. And she doesn't want to worry about any of this cybersecurity stuff. And so for us, in inserting ourselves into this process, we need to have each element of expertise to be almost brought through a chain of thought leveraging separate LLMs. And so a simple example, right? So if I'm an adversary and I want to get into your website or whatnot, I'm gonna footprint it, right? I'm gonna look at it. If you remember the old hacking exposed techniques, they still are alive and well today, right? Well, there are specialist knowledge in and around footprinting that a generalized LLM might not have. So by specifically pulling an LLM or even an SLM for that matter, and then finally tuning that footprinting LLM, you can become an expert in that one step, for example, of hacking. Same thing on the flip side for code. So now we can say, hey, we're going to scout the whole world for all of the payloads that are available today to run against this code. And now we're going to run it against this code. So we're going to test that fix. And so it's this sort of agentic style, to me, is the future of where we're going with all of this, not just AppSec, but AI in general. So that's really where, we talk about zero shot as a concept and a term, but that's just old school. It means you just type one thing and you ask the question. That's it. Multi-shot means you ask the question and then you realize the answer is not right. I've got to ask it another way, or I've got to ask it as a better example. And it's that iterative process that you manually have to do if you're doing zero shot to multi-shot, but Agentic just takes care of all that for you. So you don't need to worry.
If I'm trying to visualize algorithmically what you're talking about with multi-agent, am I thinking a couple to handful of these things communicating, or is this massive parallelism? Or maybe it could be either. What do you usually, what's the visual image I should have when I think about multi-agent?
The general sort of talk architecturally about this model is you have a sort of a brain in the middle of knows which LLM to call upon. And depending on the step, right, or the chain of thought that needs to get more answers, it calls on those individual
LLMs. Dynamic network, like a communications.
Yeah. You can think of it like
probably
that.
Could change shape depending on the problem.
Yeah, exactly. You can think of it as a main firewall, right? Okay. That has a DMZ, and then it has an internal, it has an external, or whatever. All of these that point to smaller brains, but more finely tuned, with human feedback in the loop, for example. And that gets to a really pristinely, perfectly rationalized and inferred thought from the LLM that the main LLM can take in as input and then give the best answer, most complete answer with the least errors and hallucinations.
You described something like this human AI interaction that's very familiar, I think, to most people listening, where the AI does a bunch of the heavy lifting, and then the human comes with the shovel and just fixes around the edges and cleans it up and rakes and gets it right, where the AI does the bulk of the lift. When you go through it, like with co-pilots getting things wrong, for example, when in my mind, I always think over a long period of time, there's less for the human to do. And you wonder, is there a graph somewhere where we extrapolate out to the human as, no, this looks right. I think we're good. Because you know where I'm
Well,
going with this, right? I mean, I don't know if
I
that's
know,
1 year's,
I know,
5 years, 20, but when you don't need the human with the shovel, it's a different world, right?
I know exactly where you're going with this. And a lot of people in the AI world talks about the first single person billion-dollar company, right? That many believe that one day there'll be one human and n number of agents, right? All specialized in effect that work together in concert based on your orchestration. Okay, now that's the dystopian world that a lot of the AI pundits, well, I guess we'll call it the biased AI folks are really pushing.
Yeah, it's not a very pleasant view of the future,
It's
obviously. I
not.
don't
It's
count
not.
me not part of that vision.
Now, let me just say something about this topic because I am passionate. I have 4 kids. They're all going to be looking for jobs if they aren't already, right? And they've come to me over the years and they've asked, Dad, where should I go? What should I, job wise or career wise? And I say, of course, obviously, look, you have to find your passion, whatever it is, just put your all into it. But when they specifically ask me about, like, say, programming developers, I say, well, gosh, there are certain junior level positions that are going to be really, really tough to keep a hold of. So junior programmers would be tough, which, of course, when you come out of college, you're a junior. I mean, unless you can get a lot of experience during your college career. Data analysts, right? Simple financial analysts. These are going to be tough positions to hold on to as humans. So what that means, I really think for everybody, is they have to start thinking about being what I call a creative generalist. Somebody that can tap into their soft skills, their abilities for reasoning, logic, critical thinking, troubleshooting, problem solving, communication, all these things that at the end of the day will never go away. So AI, as strong as we think it is at reasoning, it's horrible compared to the human brain. I mean, there's countless, if you just go look up a few of these benchmarks, Ed, like that everybody, you'll see a benchmark number and nobody really double clicks. And I go, what does that benchmark mean? Well, there's a huge spreadsheet of questions and answers that are correct that they throw at each of these new LLMs to see how accurate it is. And for the longest time, I mean, ChatGPT couldn't know how many R's there were in the word strawberry, right? So let's just be honest. It's not a perfect system, and it won't be for a long, long time. So that's my personal belief. I know I have a lot of naysayers out there that say that no, it'll be better than humans, within, months or years. And I think no, it'll be decades.
Yeah, the antidote I've found, and it's not an easy antidote. Let me describe it. You'll crack up at this because it's probably been the embodiment of my career. But a lot of times I'll meet with boards and other groups, and they'll bring me in as like the entertainment to talk about this kind of stuff. And when they have that
Yeah, right. That
dystopian
dancing
view,
monkey. Yeah.
the answer is to show them the math, like to
Mhm.
literally explain how basic linear regression works and to explain a little bit about how gradient descent works and to give them an instinct for how a neural network actually works. And I've
Mhm.
found, and by the way, it's not easy to do. Right? Like a lot of people forgot their high school calculus,
No,
and
but yeah, math is a 4-letter word to
it,
most.
it is. But when you kind of show them, like I invented this thing called Chat GPA, where you can calculate your grade point average, but I show them the math. But I found that when they kind of see that we're talking about mathematics and it solves a class of problems very elegantly, but it doesn't solve all problems. There's a lot of things that are left out. Then I think they start to realize that every time a new science is invented, we all go a little crazy and then we pull out the goofy part. Like mathematics, you pull numerology out, you got something.
Mhm.
Chemistry, you pull alchemy out, you got something. Astronomy, you pull astrology out, you got something. Computing, same thing. You
Yeah,
know,
no,
we pull
that's a
out
great
that
way to
we're going
put
to
it.
make artificial living. I mean, we've been trying to do that for Newton was a alchemist, right? So,
Yeah.
so I think
Yeah.
when you pull out some of the dystopian stuff, you're really left with beautiful algorithms that solve
Mhm.
problems more elegantly. Like you and I know, anything AI could do in theory could be programmed. It's just really, really, really hard. And
Yeah.
using these algorithms, it's just easier to do things we could always do. So I don't know. It doesn't always work. And believe me, it doesn't play sometimes when you're in front of a board. You go, hey, let's talk a little bit about linear algebra. That gets you invited back, right?
You are
So
a brave soul, my friend.
I do try, but it
I'm
doesn't always
you
play.
got to keep the fight alive, my
But do you
man.
agree? Like, I think when you see it with grad students, I see it with my students at NYU, when you learn what it is we're talking about, it reveals what is really at stake here. It's not magic. It's
No, 100%.
not
It's
magic.
and you got to remember the hype cycles, okay, on tech. And a lot of people when they get into these hype cycles, they think like there will never be another hype cycle, and this hype cycle will never go down. There'll
Yeah.
never be a disinterest in what we're talking about, whether it be, remember, it was cloud, it was mobile, it was internet browser, whatever, but it all dies down. And you get to more clear, realistic picture of where we can really leverage this technology and where it's going to make your life better, additive, not detractive. And we are still in that I'll call it, the first three innings, since we just talked about
Yeah.
baseball a lot right now, but the first three innings of all of this stuff, and we'll start to see where it settles, in the next couple of years. I don't think it'll be as hyped up. I mean, even if OpenAI or anyone else comes out with, oh, well, we have AGI, we have artificial generalized intelligence, we have a human being that is the confluence of all human beings ever documented on Earth, and it has emotions, it has feelings, it has empathy, as it blah blah blah. You're trust me, we're gonna find problems in that world too. It's built by humans. It's gonna be flawed, just like humans.
Let me ask you about your company, about Quiet. As you've been building the tools, curious what that's maybe you've been asked this before, but what has sort of surprised you? Like, have there been some problems that turned out to be a hell of a lot harder than you thought? And maybe some that you thought would be hard that turned out to be, wow, this is a little bit easier. What's been your experience building this tool? I bet for a lot of people listening right now, they might be in a similar sort of setting where they're being asked to apply or build or do something using AI. I'd love to hear what some of your insights have been based on your experience at building
Yeah,
the.
yeah, for sure. I mean, so when I came into Shift Left and really saw the opportunity to rebrand and sort of change into Quiet and sort of apply AI into this field, I saw our core technology, which is this code property graph, this vectorizing of code approach, as being magical. We just needed to capture it. We need to leverage it in the AI realm. And so that's what we did. Now, the models themselves of bad, because of that vectorized database that we already have of good and bad, that was actually pretty straightforward. That's why 6, 7, 8 months later, after I got in there, it was easy to deliver on that, the predictive models. Where we knew we were going to have more challenges was in and around the generative and the auto fixing side. So we launched that this May, and I guess and we were only one of maybe 2 or 3 folks talking about it at that time. And within 3 or 4 months, of course, everybody starts talking about it, saying that they can do it and they've done it. But I think where they're really having a hard time now is they're realizing the limitations of these LLMs, especially when you look at just the code itself. So if you just look at the syntax of the code, you start to get extreme hallucinations and extreme error rates. And this is where our code property graph has been absolute magic. And that's been a real boon. Now, some of the areas that I actually didn't anticipate was how quickly everybody would be using AI to generate their code. So, like, I don't know if you saw recently, CEO at Google, of course, came forward and said, yeah, 25% of all of our code right now is being written by Gen AI. And you
By the
hear
way, I
Git,
never believe a number that ends in something so smooth.
so easy, right? Exactly. I want to see 2 digits past the decimal.
If
No,
something ain't right, if
yeah,
it's 25, 50, or 75, that ain't right.
yeah, and you trust like GitHub, right, which sort of tries to measure this stuff, and it's like, oh, it's 60, 70, 80% of code being generated. And you're like, oh, come on, give me
Yeah.
a I don't know how you're measuring all this stuff, but let's even say it's 10%. We're like, let's just discount the heck out of all of these numbers. and let's say 10%. That means that 1 out of 10 developers is just an AI in effect, right?
Yeah.
All right. So what I realized quickly was absolutely developers today can leverage AI to move very, very, very fast, much faster than they would have prior to Gen AI being a part of it. But what they're finding out is they have 10 times as many errors to go fix, 10 times as many limitations to go fill in the gap, or 10 times as many hallucinations to be able to identify and then remove. Now, as a human, you might think that's perfect because now they've got full-time jobs plus they can just go work on these error rates, but you're trading one problem for another, and it's something that really everybody, every leader, every people manager has to think about is, what are you trading for speed? And is the ultimate trade-off a net positive or net negative? And I think that's the key. So at least in terms of discoveries for us, so we will certainly leverage AI when it's the right choice, but I really caution everybody to find that place of point of diminishing returns where, yeah, okay, it might be able to accelerate that initial development of the initial modules or libraries of code, but then stop and
Right.
bring it all together yourself in your brain, and then start to do the unit tests individually, fix things along the way, and see how it works. So to me, that is the better best practice approach right now.
Like that. So we got some good questions here. I
Oh,
hope you
awesome.
got your thinking cap on. First
Let's.
one is not a question, but poor Ali is saying, Ed, this is the second time I saw you on a forum this week. I'm like, oh God, I'm getting too overexposed. It was Venables and I did something on non-human identity this week, I think so. So
Oh,
hopefully it's
nice.
okay. Your old buddy Phil. So he and I did
Oh,
that.
I got to talk to him because I need to solve the proof of personhood problem too somehow. But yeah, go ahead.
Yeah.
Okay.
So Carlos had a good question. Carlos is saying, listen, we're deploying all these SaaS tools. You might have check marks and Veracode and all this other stuff, and S-bombs that people are using and compositional analysis, you name it. And he mentions code property graph, which is at the root of a lot of these
Yeah.
tech tools. If I want to do something with you guys, where are you kind of fitting in? How does it integrate? How does it
Yeah.
connect to my existing? It's either going to be a mess or something you're proud of. More people would call it a mess, but
Yeah.
how do you roll into that?
So, it's very similar, Ed, you'll appreciate this, to the AV world, right? So antivirus world. So when I started Silence, I used to get the same question, well, where do you fit in, blah, blah, blah. And it's the same. You have the legacy players, the folks that sort of created the whole space, right? So Chris Weissopel over at Veracode, right? They're what we call a legacy or an incumbent, right? Checkmarks is another one now that's come up, but Fortify, there's countless Synopsys, things like this. Those are legacy players, and will often come in and really elevate, replace them and elevate the developer experience, but also the development output and productivity and quality because of the AI. Then you have these emerging vendors, folks like Sneak or maybe Mend or something, and we'll often come in the same exercise talk about, well, how powerful the true native application of AI in code and AppSec might be for you. And they'll come side by side and will often sort of replace those solutions. Now, there are the third group, though, that look at us as adding to the tech stack, and we can do that. So we can say, all right, well, look, you love, I don't know, Veracode. I've never heard anybody say that, but let's just say you love Veracode, no problem. But we can come in and look at the code and suggest the best fix using our agentic autonomous system. So what you'll get is not a fix that comes from probably, Copilot or something else, but a fix with a multi-layered, multi-intelligent chain of thought system that could give you the purest, the most accurate representation of that fix, and then ultimately be able to test it and validate it over time. So when it comes to competitors, the answer is yes, we have them all, SBOM solutions as well, but we are really focused on that holistic solution using pure math and AI to solve the problem, not just of finding, but of fixing and releasing. And to us, that's where we believe most companies orient themselves in defining, fixing, releasing, and leveraging AI in the best possible way. So that's where we're getting a lot of the traction.
George has a cool question about evaluating AI models that you guys have probably thought about. And he references a topic that you see a lot on Substacks and things around vibe. I'm not much of an expert there, but I have spent a little time thinking about model evaluation. What do you think? What's the state or what's the status of how AI models today are evaluated?
I think there's the way that most models that I've ever worked with in evaluating AI models for efficacy, et cetera, they typically do, the kindergartner through maybe, grad school sort of questions,
And this is LLM, mostly
Yeah,
LLMs.
yeah, mostly LLM, exactly. The predictive models are tougher to measure. You really need independent teams that have access to large data sets. But for the auto fixing and generative stuff, there's a lot of different models, and they each measurement of these models is going to be different, and there's going to be subcategories, et cetera. Where I think we've really not tapped into much is in and around the reasoning part. I think we're barely beginning to test these models properly for full human reasoning. And you start to see this in a lot of these like MMLUs and such. And the reason is because, okay, so your brain, Ed, my brain, all of our brains, right? We can imagine something before we say it, before we do it, right? Well, AI really can't do that. I mean, not yet. It can't really take a concept, think of it, and then work it through before producing it. Now, the first model that really is starting to think about like this is called ChatGPT 401 with the chain of thought. So it's doing that in the hidden layer, in effect, versus at the inference layer. And so it is the first beginnings of it, but none of the benchmarks really, I think, do it justice. I actually love some of the YouTuber guys. They'll ask questions like, okay, if I'm Bilbo Baggins and I'm going to get on a train to London and I'm going to listen to the audiobook of Harry Potter series, how, what book will I be at in reading through that sequentially once I get to London? I mean, that's a full-blown like reason. Every single one of those gets it wrong, outside of maybe 401. Okay. Like, so it's just, remember, just like the AI models are getting better, so are the evaluation systems that are evaluating these models for efficacy and accuracy. And so we have to wait, give it time. And I encourage everybody to double click on all that stuff.
Yeah, I think that's sensible. Hey, we got time for one more question here, and it's a good one. Lorenzo has a question I think he could probably patent, although maybe you tell me if this is unique. He's asking whether there are algorithms where you can sort of chain the output of AI agents, where they're all working in concert, and the wording he uses, the output of a previous agent used for generation of the following one. That sounds like a chaining kind of thing to me, but have you ever seen anybody do that, or do you guys have schemes that work that way?
Well, that's exactly where we're going, right? With our
Oh, darn it. No patent, no patent. Sorry, Lorenzo.
No, I mean,
That's a good idea, right?
we have a process. We have actually a provisional patent on this, which is taking multiple agents in a cycle, in a sequence, and applying them into this analysis of code and the fix of the code to produce the best fix. Given, again, the state of the vulnerabilities out there for a particular software package, given the state of the adversary in terms of the infrastructure being used, state of the techniques, all of that stuff, and these specialized agents in working together to give the best fix and then ultimately the best test and validate. So it is a core part of what we're trying to do.
I mean, chaining, if it's strengthening, like in the context of blockchain for like a cryptocurrency or for a log, a ledger, is a great idea. But it seems like that type of algorithm would be susceptible for the same reason that we play telephone tag as kids and the message gets garbled, that it would seem like it would be very susceptible to accelerating or amplifying a hallucination, in a chain.
Yeah.
It would seem like that could happen. But I haven't spent much.
You would think that, but actually in practice, it's the opposite.
It figures
Because
it out.
it does. So
No,
because you have
how would
so
it
many,
know? How would it figure it out?
so just like if you get into a group, let's say, right, you're in a meeting in your office and you have one problem for all of you to solve. If
Right.
just one person says, well, here's the solution and you guys need to go along with it, well, that's probably going to be a high error rate, right? If, however, you have
That's how
everybody,
we work at Tag. I say do it, and it's always wrong, and we go down the wrong
I
path.
figured, man, we just follow your lead, right? Well, it wouldn't go wrong all the time, but sometimes it would. So, but
Okay.
what if, right? Everybody in your team, in your meeting, was very different, cognitive diversity of the team. So, very different way of thinking. So, one person
Uh,
might be highly emotional, one person might not be at all, and more data driven. One person might be a big ideas person, one person might be like, no, 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 I need practical. How do we get the one person might be a total like a mess, and completely unstructured, and one's very structured. They need things very regimented. Anyway, you get the gist. If you create a cognitively diverse team and you present one problem, you need the input from everybody else to feed into the decision making, so you get the best answer with the least error rate and the least hallucinations, etc. And that's exactly what's happening now in this autonomous agentic world.
oh, I love that. I could listen to you all day long. I know you have a nonprofit that you're part of there, Children's
I
Hospital.
do. I get to hand out candy to sick kids in a hospital here at Chalk Hospital in Orange in California. So I get to dress up as peanut butter. My wife's going to be jelly, and we're going to walk out here in about 5-10 minutes and go do that. So I'm just glad we got a chance to catch up, Ed. It's always good to see you and hear from you. And thanks so much again for joining.
It's been a delight, really, really pleasure. Brian, we'll turn it over to you to close.
Yeah, no, thank you both, Stu and Ed, and thanks everyone for attending. As a reminder, we'll send out a recording to this. I know there were a few questions we didn't get to, but we'll be sure to follow up via email. I know one was asked anonymously, so if you don't mind sharing your email, we'll gladly follow up there. And then, yeah, we'll be sending this out as well as updates around future webinars that will continue on this topic. We'll be taking a more technical view, a practitioner point of view, and really trying to round out this topic as, I think Ed and Stu have really kind of highlighted. This is going to be the future of where we're going with application security. So again, thank you. Thanks, Ed and Stu, and we'll see you all again soon.
Take
Thanks,
care.
everybody. Take care, guys. Bye.